Welcome to another lesson. We are going to be continuing our experiments with libSDL version 2. Let's take a look at what we have so far. I'm going to compile with G++ and link with SDL2 library. Execute the program. We can move the player represented by the gray square, and it's capped to the screen so it cannot go out of bounds. I'm trying to go to the right again, but it won't go out of the screen. Trying to go down again, I'm pressing down, won't go off the screen. Pressing left, it won't go off the screen, and so on. Now the goal for us will be to make some sort of game map. So where we're going is the following. We're going towards some kind of labyrinth game. Let's take a look at this picture here. So we are going to have the screen split into squares. These tiny smaller squares, like the player right now that is moving, is called a tile. We are going to split the screen into tiles of 32 by 32 pixels, okay? So there will be a game map, and the map will cover the whole screen. And the purpose of that will be to eventually make a labyrinth game. And this game would be something like this. Suppose there are walls here represented by the color white. The background is black, meaning you can still walk through, but you cannot, when you hit the wall, you cannot go through it. So it's some sort of labyrinth where you start at some point, for example, at the top left, and you have to reach some end point. It could be anywhere. We could mark some endpoint, perhaps here, and then you have the start point, perhaps in the top left. So your objective would be to go from the top left to this square marked with the red color here in the right hand side. So there will be many obstacles, and those obstacles would be the wall represented by color white. So you could have the map with the walls, so you have to go around the walls and find a way to reach that destination. Of course, I'm drawing pretty bad, but you get the point, right? So let's get started here. We're going to first see how we can draw these tiles. Now we need a map, and that's something we have to think about. We're going to use a simple format for the map. We are going to take a text file and make that our map. So in the text file, we're going to use numbers to represent what kind of tile we are drawing. For example, if we want the black tile, which means you can walk through, there will be 0. And for the wall tile, represented by the color white, would be 1, meaning you cannot go through. It's a block. It blocks you. So let's start thinking about how to do that. So let's go here. Let's make the sample map. Let's first figure out for our screen how many tiles it will fit. Remember that the screen width is 640 and the window and the height is 480. So we're going to take that and divide by 32. So 640 divided by 32 would be how many tiles? 20 tiles, right? .480 divided by 32 would be 15 tiles. Okay. Now let's figure out how to make the map format. I'm going to create a new file here. And this is going to be the format of the map. We're going to have, so 20 tiles, right, per row, and 15 columns. So let me start with just 0. 0 represents a tile that you can walk through. So the first on the top left is here, and then you add 19 more, right? So now we have, and they're separated by space, very important. So we have 5, let me add more, 5, 10, 15, and that's 20. I removed the space from the last one and I add a new line. So here we have the first row would correspond to from the top left to the top right. There will be 20 tiles, each represented. Each would show up as a 0 tile. The 0 represents the tile that can be walked through. We're going to use the color black for that one. 1, 2, 3, and so on. So you see there's 5 plus 5 plus 5 plus 5, 20. And we're going to do the same thing, 15 rows. Just to start with nothing in the map. And we're going to demonstrate as we add a different kind of tile how to show it and load it in the game. So I'm going to do 1, 2, 3, 4, 5 rows, and I'm going to copy this and add 10 rows, 15 rows now. And let's call this the game. Let's call this game map.txt. Now let's find a way to load this game map into our program, our game. Let's go to main.cpp here. So as we start the game, you want to first load the map, and then you want to create some kind of surface, right? And that surface, you're going to paint the map once, and then from that we can continually print that onto the window surface. All right. So let's make a function for that. For now, just void. Let's do load game map. No parameters for now. So we're gonna need a way to read a file. To read a file, we can use the fstream library, right? So we're gonna go up here, and I'm gonna say include fstream. With that, I can use a class called ifstream, okay? And this can be used to read the file, okay? Let's call it game map file. And you have to give the name of the file, right? Let's do game map.txt. That's how we named it. So we're gonna get this. Now what? Now let's try to see how we can read this. Let's see what happens. I'm just gonna output the result to the screen just for debugging. If we do string line by line, it would be something like perhaps. So we're gonna check the file open, then later we're gonna read every line and then we close it. So game map file is open. We're going to do something, and then at the end we do game map file dot close. Then we got to read each line. If I just do C out, not cout, sorry, get line. And then we give the map, game map file, the instance of ifstream, followed by a variable to hold the string. And that will get you the line into this line, and you can do, let's see out what's in line just to see. And I forget the cd : standard library. So let's do the first one. This is just gonna get the first line. I want to see what we get in the terminal. I'm gonna restart. Oops, I have to compile again. Out. And there's a problem because I forgot probably std the color for string. Perhaps you want to include the string, include string here. No, ifstream is not declared. Is it also part of the namespace? Let me see. Probably is. I don't know. Let me check. Yeah, it is. So ifstream is also in the namespace std. Okay, so we didn't call the function, so let's call it from main. After starting, we initialize SDL, create the window, and so on. Let's do after creating the window surface. Let's do load game map, and let's call that function. This will call the function we declared here. And you can see it's reading the first line. Now we can do it for every line if we put a loop here. While get line. And with that, it will read every line. You can see now the map is red and we have access to it. Now the problem is we need to grab each individually, not just line by line. So let's see if we can do something about that. Let's see if scene works here. Let me look about reference C++. C++ scene. Let me see if there's an example of files somewhere. In here. So it's a stream. So let's think about this. If I have a stream and you stream use the operator here to whatever variable. Okay, let's see something here. Let me comment this out. I'm going to do the following. I'm going to do cin, right? Oh, sorry. Game map file, and I'm going to use this operator into, I'm going to put some variable here. Let's say int tile ID. Now I'm going to put there, and I'm going to std out tile ID. See if that gets the very first one. And I need a std end line just to break the line. So we got 0. Now we gotta go for all the other ones. So we gotta find a way to loop through. Let me okay, loop cin ifstream. Look, ifstream. What is this one? I was looking for this. Seems like we can do that, perhaps. ifstream. Okay, let's try that. Let me close that. I was just confirming that if we do the same, would this work, I wonder. Let's do it. Not if, but while. And you go here. Let's do okay, seems to have done everything. It should be like how many? 15 times 20, right? So there'll be 300 tiles, right? 15 times 2, 30 times 10, 300. Let me pipe this to word count. Oh, it doesn't work. Yeah, 300. One is because of the starting, so 300 tiles. Okay. So with that, what should we do now? Let's put this in. So if you have the map, you want to be able to draw the rectangles. Now that's something we can do, but I'm thinking we don't want to do that in the same function as load game map. This function should only be responsible for getting that data and put it into memory. I don't think there should be separate functions just to draw. Okay, since we're dealing with a fixed map size, perhaps you could do a 2D array to store all the tile IDs. Of course, you can use a single dimensional. That would be a 300 size. And that's totally fine. But we can also do 2D, up to you. Let's see what we can do here. If it were to be just one, so it would be an array of ints. So, let's see. In this case, would be a pointer, right? So load game map, let's see. So let's create an array of int. So int tiles. We can start one dimension and then change to 2. Let's do that. Int tiles 300. Then we go through the game, get the tile and so on. Instead of doing the cout, you're gonna say tiles at some index. So you can say int index equals 0, and we put this inside. At index equals tile ID, and then at the end index plus plus. Remove that, close the map file. After that, you can return tiles. And let's see, address of local variable returned. Yeah, we have load game map. You can get game map tiles. Let's see. That would be a pointer, so I have to re-reference. Let's see. Think about that. So we got that. Let's do the following. Instead of doing that, let's pass it by reference. Load game map, we're gonna do here. Don't do that. And then we're gonna do here, we take that to be the dials. Int. And then let's go here, we're calling like this, and then we do load game map tiles. Then we have to maybe pass by reference. Let's see. I think can recall. I have a syntax blank right now. Let's see. So we have an array here. Map tiles equals 300. If we don't have this, comment this out. Let's say I have 300 there. And if I do that, standard cout game map tiles 0 std end line. What do we get there? So I don't need the WC. So it would be 1. Fine. Now do that. What would it be? 0. Okay. Fine. So let's call that with game map tiles. Let's see, you had game map tiles here. You have the tiles int ampersand. Let's say tile sub 0 is 3 or 2. And then you standard out sub 0 here. Invalid types, let's see. 9 lane 7. Oh, because it's int, sorry. So that would be like that. Is that it? Array of references. Like that. Well, that gives a copy, so it's not really what I want, is it? All right. So tiles of 0 is 2. Map tiles of 0. They're not the same. So stall is an arbitrary value because it's not really setting, and I'm assuming it's all coming from this. It's not set, so it's not really setting anything. When I pass that, pass it here. If a reference is being passed, not actually changing the thing. If I do that, what happens? Real references. So, what happens if I do this? Cannot convert. Argument 1. Okay. Let me see something. Int map tiles that, okay. If pass. Map tiles as is should be press, come here, say it's a pointer to int. And you got that, you got that, but you have to correct. Okay, here you go. That's fine. Now let's bring this back. Oh, this part here I don't need. Yeah, the shadows of parameter because I declare the parameter with the same local variable name. Okay, we got that. Let me remove this. So I create the game map. I'm not gonna. Well, I could initialize to 0. Let's see. For debugging purposes, I'm gonna make a function here to print the game map. So I'm gonna call it print game map. Okay, and I'm gonna take the array of tiles and I'm gonna do just a loop for I equals 0, I less. Oops, I don't have length, so I'm gonna do 300. And this would be this part. I'm gonna put I here, and I don't want to do the end line until, so like it's every row has 20, so every 20 I have to add a new line. So if I% 20 equals, let me think about 0. 0 will be the first one, add a new line. So we go through it. The first one is 0. 0, as long as the I is not 0. And it is gonna be at the end of the line, because if you reach the end of the line, let me think. Actually, it should be, yeah. As you reach the next one, you should add a new Standard C out. Maybe they should be at the beginning. If I am at the about to print the very first of the next row, then I am going to add a new line. Let's see. Load game map, print game map. This is printing to the console, by the way. So we can debug. I don't need this. It's JavaScript. This is C++, so 2 double equals. So something's not right. And I need a space. So we got 0, 1, 2, 3, whatever. Oh, I forgot what tiles at. There you go. Now we got a debugging map here. Now we gotta print this map. Let's see what we can do about that. Let's create a function to make the map surface. Create map surface. And we're gonna pass the game map tiles. And let's see, we're gonna return a SDL surface star, pointer to a surface. Let's say map surface, game map surface. Okay, let's come here and say SDL surface star is the return value. Create game map surface and star tiles. Put pointer to a int. Let's do. So we need SDL surface star. Let's call it map surface or just surface, whatever. And let's do, we need to create the surface. So how can we do that? Create Rgb Surface, we can perhaps use that. How about we take this? We're gonna call SDL create Rgb Surface. Here are the arguments. Oops. 640 by 480. That's the window width and height. It's from here. Probably want to use those concepts somehow. Later we probably can make a class and have this being accessed from this method. But right now we have kind of a mess. So let's just go with that. And I noticed there's no break line here, so after print, maybe I want to add std and line here. C out. Okay, so 0, 0, 0, fine. Actually, let's put another color so we can know, because 0 is gonna be black and it's gonna be the thing. So let me look for create Rgb surface. Let's see how they're doing this. With height and this. R mask, G mask, B mask. SDL interprets each byte as a 32-bit number, so our mask must depend on the endianness byte order of the machine. I see. So we gotta do that the same. RGB. Anyway, let's try something. You went 32. RGB. Let me copy this. I don't know if that's going to be really a problem, but I just want to make a mask here. Let's do slightly red for the background. So I'm going to say UN32 of the type our mask. And I'm going to say it's slightly red, not everything. So this is a hex value. Okay, start 0x means the value starts hexadecimal. Red, green, blue, alpha. Got it? For every digit, every 2 digits to something. Red, green, blue, alpha. So I'm gonna do, this is black. So I'm gonna do maybe slightly 1, 2, 3, 4, 5, up to 9. Let's see what 9 does. 0, 9 for red. And then I'm gonna use this here, R mask. And since it's using the endianness here, it kind of inverts the R. If the byte order is not big endian, you have to do the opposite. Like our mask is going to be flipped. So the 09 is going to be at the end. So 00, 00, 00, 00, 09. You can see here, it's just kind of inverted horizontally. Okay, let's try that. We got that, then we return that actually. So even, actually didn't even need to create this, we can just return. Let's see what that does. Let's see if it doesn't give us an error. Not declared in the scope. Okay. I didn't put the game in the name here when calling the function. Good, okay, no problem. Let's store that, game map surface. Now let's paint that every time. So since we built the surface, we have to paint that onto the window every time. So here, when you're painting at the window, okay, we have to paint somehow. So this one was with fill rect. Now we had to find a way to paint onto the window. So I think, what is it, blit surface, use this function for a fast surface copy to a destination surface. Let's try this function, blit surface. So we're gonna do the map. Let's remove all these things we did. We don't need them anymore. I'm gonna remove it. Okay. And just the player now, and I'm gonna put the map there. We're gonna do, oops. We're gonna do SDL blit surface. Now what's the source surface? Would be window surface. What's the area? No means everything. Otherwise it's SDL rec with the part of the surface, the area of the surface. Destination, oh, actually I got this inverted. The source would be the game map surface, and the destination as a third argument would be window surface. We're copying that from game surface onto the window surface. And it would be everything. So we're copying the whole game map surface into the whole window surface. Null means whole, null means whole. And if you want to just part of the game map surface, you would put a SDL rect with the clip here. If you want to just to paint onto part of the window surface, you would put an SDL rect, a reference to it here. I forget the semicolon. Okay. That's strange, yeah? It's like I'm moving and it's filling the things. Anyway, it didn't work. So I wonder why. To be copied from. Oh my god. Okay, so actually I was right in the first time. The SRC to be copied from. No, wait. Is the blade target. Blade surface. So select. Copied into. No, that was correct. So what could be wrong now? Windows surface plate position. It's being filled. This is not. If I didn't have the game map surface, what would happen? Let's see. Oh, it seems like it's not even doing anything. No, we gotta fix this. If there was a way of us split surface, maybe there was an error. Int return 0 to bit successful or negative error code on failure. Okay, let's check if there's any problems. If SDL blade surface is not 0, SDL log, there was a problem onto the Windows surface. And we can do %s and then corresponding get SDL get error, remember? For the error. Let's see if there's any problems. Okay, there is a problem. So let's stop this. There was a problem hitting blade the game map surface into the Windows surface past the no surface upper blade. So it seems like there's a no surface. Probably we didn't check for no for the game map, right? So if game map surface is null, something happened. SDL log failed to create game map surface, and we put the %s and SDL get error here to see. And also let's make sure to liberate memory for the game map surface at the end. So at the end I'm going to SDL free, I think it's free surface. Look at the wiki. Free surface, yeah. Free surface, game map surface. So we can deallocate the memory that was allocated for that surface because we don't need it anymore. So we gotta collect our own garbage. Okay, I must do something here. I should probably stop everything. Failed to create game map surface. I'm gonna do a return 3 in case that happens. And for the other one, I'm gonna do return 4. Just gonna stop everything because we don't have any error handling right now. Failed to create game map, a no pixel format. Okay. So we got a problem here. Could it be the R mask? I wonder if I messed up there. I'm gonna comment this out and put like that. Comment this out. Let's see. Yeah, that was the problem, Let's see. So this was the problem here. I don't know why it didn't go so well. Rgb Surface. Let's look at the example again. R mask. UN32. Read surface. Give the R mask here. Change Rgb surface. What happens if I were to give this, for example, 32? unknown pixel format. I give 0x ff000000. Unknown pixel format 000000ff. Unknown pixel format. Width height 32 R mask. RGB A mask parameters are bit masks used to extract a color from a pixel. Extract that color means the red data is stored in the most significant byte. Using 0 for the RGB set to default value. Oh, okay. Oh, wait. Hold on. Maybe we should do the following. We should paint a rectangle instead. Or not do anything at all, actually. So we're probably good here. We can use 0. Never mind. Let's just do like that. So we got the game map surface. And then we gotta paint onto that surface, right? So actually we needed that SDL surface. And then we have that, it's empty. We need to draw the map now. Draw the map. At the end, we're gonna return the pointer to the surface, but we need to draw something. So we're gonna do a fill rect for every tile. So let's do it. Okay, so let's see. We're doing one dimensional, so every 20 we gotta break the line. So we're gonna do, let's do the following. Let's set row and then set column. 2 variables. And then we're gonna go in a loop. And we're gonna go from, we can do left to right column and then go to the next row, or we can do top to bottom and go through column, whole row top to bottom and column by column. It's up to you. Let's do it here. Let's do like the top row first, then the next row and the next row and so on. So while the row is less than the total number of rows, in this case will be 15, right? Because 480 divided by 32. Of course, all these variables probably you have to use a constant, so we don't have to type the hard-coded value somewhere. So let's do that. At the end, make sure to increase the row. Don't forget, otherwise an infinite loop. So we're gonna do the following. Let's see. We're gonna say, okay, you do SDL, fill rect, and then what's the, oh, there's even fill rects we could use if you want to do this one, but I'm gonna do the individual. So first is the destination surface, would be the surface here, pointer to that, and then a rect, or so the rect would be the area we want to cover, so we're gonna make that rectangle. So this would be the position, the XY, width and height. Width and height at the end, I'm gonna type, would be 32 by 32 already, but the X and Y would change. So we gotta change that. I put 0, 0 here, but it's not gonna be 0, 0 actually. So let's break the line here. Actually, it's probably better if you did without this thing. So maybe you want to do separate rectangle.x. I'm gonna put rectangle.w is 32, rectangle height is 32, and probably we can move this out of the loop. We do, because they're all the same size. So I'm gonna do that. And we have the position to change because we're gonna be drawing the map. The first one is gonna be 0, and then it's gonna be 0 plus 32, and then 0 plus 2 times 32, 0 plus 3 times 32, and so on, right? So that will be, what's the variable that's doing the changing every time? It's 1, 0, then 1, and 2, and 3, and so on. That's a row, not the row, right? Here, in this case, would be the column, because we're doing column first. So you want to do column. But then you gotta loop through the column. Right, so you gotta do while column is less than the last column, would be the 20 if you keep doing this. And then you gotta make sure to increase the column here. And then once that is done, let's see, you gotta think about resetting the column and then increasing the row. So you reset the column back to 0 and then you increase the row to go to the next row. So that's why it's important to have that. Now let's go back to this. So we got the column times what? The tile size, right? We can make it a constant here somewhere, but I'm going to just do it 32, maybe to do tile size constant. Something we could do later. So 0, 32, and so on. Now for the y, that would be depending on the row, right? The first row would be 0, and then the next one, second row would be 32, and so on. So this will be row times 32. And then you can pass the address of rectangle. That's going to be the area of the surface where we're going to paint, because we're painting squares, little squares through the whole surface. And then we do the color. We said it was going to be black, right, for the one you want to walk through, but we can increase a little bit the color just to see that it's actually drawing. So let's do that. But mind you that the color is going to change actually, because the color changes based on what kind of tile it is. That's why we have the tiles here. No wonder it's there. So we need to grab that. So we can say int current tile ID. Now we need to grab tile sub what? Well, you have to think about the grid here. So you have, let me duplicate this. Never mind. So you have, let me draw here. You have 0, tile, 1, 2, 3, 4, 5, and so on, right? And then this is going to go to what? 0 through 19, because it's always 1 less. And then 20 is going to be the next row. And you could guess it's going to go to 39. And then 40 is going to be the next row. And so on, right? So you can already figure out how to get this. So you give, okay, what row are we in? If depending on the row, we add 20, right? And depending on the column, you add whatever the column is. So you get the row. If I'm row 0, then times 20 plus the column. Let's think about that. If you are 0, does that make sense, this formula? So 0 times 20, 0 plus column 0, 0. If you're the next one, the column would be 1. So row would be 0, so column 1, 2, 3, and so on to 19. Now if you do the next one, if the row is 1, 1 times 20, 20, column 0 would be at 20, correct? As you increase column, it goes through to the last at 39, and so on. So it's correct. I think it's correct. So let's save that. So finally, we can figure out what the color is going to be. So let's see, tile color, the variable here. And let's figure out what that is. Remember, that's probably you went. You need to make a RGB map RGB, right? Map RGB to get the color. Oops, I opened a new tab. Let's see here. So we can use this to get the color. So let's do that. SDL map RGB. And the format has to be the surface in reference to the format. And then you give the values for each color. So for example, if the current tile ID is 0, that means it's a walkable tile, right? Walkable tile. Let's give it a color. Originally we said it would be black, but we can change it right now so we can see it's actually drawing, and later we can change it back. So we're gonna do this thing here. I'm gonna say tile color equals. Let's put a variable here. Uint32, because that's what it's returned from the SDL map RGB function. Oops. And so let's put the tile color here. Let me make sure I'm doing this right. Oops, that's not correct. It'll be 0, 0, 0, right? RGB. And then you take that and finally put it here in SDL field rec as the third argument. Right now, that's the only color we have, so we're gonna do else ifs later, right? Else if current tile ID is 1. This is like the wall tile blocks you. It's to do. Right now we don't have anything. We said the color would be white color, so we can do map RGB surface format, the format of the surface. Then we can do 255, 255, 255. Let's increase the color here for the walkable tile so we can see something is actually being painted. I'm going to do 44 then change back later. So we fill rec and do everything. Let's test it out, see if it didn't mess anything up. So here's, you can see every tile now is 0, and the corresponding 44, 44, 44 is now being painted in the background of the map. Now you can see the debugging representation of the map in the text file. If I change it, for example, let's say the second one is 1, 1. We expect what? If you look at the top, the second from the left and the third from the left are gonna be white. Let's try it out again. So I changed the map. See, now it's white. And that's gonna be the blockable tile that we're gonna block. If the user tries to collide with that, we cannot go through. Right now it's just allowed, right? You can walk through, but that's not gonna be the case later. So that's the map, right? So let's see what we did. We have a text file to represent the map. So each integer here, right, corresponds to a type of tile. 0 means a walkable tile. That's this kind of a darkish color. 1 means a wall tile. That's going to be the wall of the labyrinth where you cannot go through. And it's separated by space. So each tile separated by space and separated by rows. So each row is a row here of the screen. So this is the first row, corresponds to this. The last row here at the bottom of the screen corresponds to here, and so on. So have rows, right? 15, because 480 is the height of the screen. 480 divided by 32, the size of the tile, would yield 15 tiles from top to bottom. Now for each column, right, from left to right, we have 640 is the window width. Divide by 32, you get 20 tiles across. So you get 20 tiles from left to right. So that's why I have 20 numbers from left to right, and you have 15 rows. And you can change and make your own map here. I can start changing it and building the walls here, here. And later we're gonna figure out where to place the starting point and the end point of this labyrinth game. All right, I can save that map and it's gonna load it again. You can see the debugging shows you the data representation of what you see on the screen, right? All right. So I think that's it for this stream. And if you don't know about us yet, check out NBK Tech World. And I hope to see you next time where we continue to build this labyrinth game. Thank you so much for watching.